So let's go back to here. So in order to plot this, we need values for U and A. To be able to do it, we need some information. So you imagine you were doing this in an engineering environment, and you did an experiment. And this was some sort of object that was moving. It could be a slider moving up and down a machine, or it could be some object, literally a car or something. So what you do is, you get some values, you do an experiment. We let this thing move, and we notice that after 13.68 seconds, the displacement, how far has it gone? 918.344 meters. So we've measured it pretty accurately to the nearest millimeter. And then it's continuing to move, so it's one experiment. We note after 68.4 seconds that it's now at a distance of 22,950.39 meters. That allows us to set up two equations to find U and A. We've got two unknowns, U and A, so we need two equations, two scenarios, two sets of information to be able to find what they are. So, what do we plot? Here's the function. So what we do is, we know S. It's 918.344 equals. We don't know U, so that's just left as U. We know that the time, though, is 13.68. So it's U times 13.68, or 13.68 U, to put the letter after the number, okay? Equals, plus a half A, so 0.5 times A times T squared. Well, we know T, so 0.5 times T squared, which is 13.68 squared. So that's a little calculation I've got to do, and then that's times by A. So that is the first equation. We've used the information from the experiment, the first set of information, to set up an equation by replacing S and T with the values that we know. What about the second equation? Just write down what the second equation would look like. So second equation will be this. Now we want to try and solve it. Well, we're not going to attempt to do this algebraically. What are we going to do? Plot it on autograph, okay? Work out the numbers as far as you go. Autograph is not going to like you putting this in, 0.5 times 13.68 squared. So work out what that is and work out what that is. Okay, so we now have two simultaneous equations that we can plot on autograph. One more thing to do before we can plot them. What's that? Yeah, we've got to assign X and Y to U and A, because autograph doesn't recognize U and A as variables. So let's let U equal X and A equal Y. It doesn't matter which we call which, but let's do it that way around. And now we can plot those onto autograph. So plot them. So here are the two equations down here entered. Obviously we can't see them because we're looking in the thousands here, so we need to zoom out, I would guess, quite a lot to be able to see them. So let's zoom out. Here they are. Now, to be able to get it, we need to use these buttons here to change the axes around. Everything is happening within quite a small band in the y-axis here, so we could do with zooming in on the y-axis to open out these values. So if you want to open out the line so they're not right close to each other, that's what we can do. So now we can zoom in on it. Zoom box in on this point here. Now we can start to see that it's all happening around this point here. So again, we could do with zooming in maybe on the y-axis to separate out these points. and then zoom in again. So it's using the buttons on Autograph to zoom in on the values. Now we can come up with some values for X and Y. So if we arrow down and arrow across, we can come up with values for X and Y. I probably zoomed in a bit far. 9.81 and 0.03 will probably do us for values for X and Y.